ಮ್ಯೂಟ್ ಮಾಡ್ತೇನೆ ಎಂದು. Good evening, sir. Discussion topic neural network for the term deposit subscription predictive. Myself, Abhishek. My team members Jitendra Patil, Karthik R, and Ravi Kumar. Neural network for term deposit subscription prediction. Explore the how machine learning and neural network transform banking marketing strategy. Discover the predictive accuracy rate up to 90%. Learn aware advanced AI driving targeting can enhance customer. The challenge in bank marketing. Banks focus difficult identify the potential term deposit subscribes using the traditional methods. Low conversion rates, less conversion marketing. Here the critical needed for a data-driven predictive models, improving the targeting, increasing the economic complexity adds to these marketing challenges. Neural network architecture, multi-layer protection. The network uses multi-layer architecture, feature processing the large arrow client data, non-linear capture complex data relationship, enhancing prediction accuracy. Key predictive feature, client demographic, transfer history, economic indicator, complex response. The models leverages client demography, banking history, and economic indicative price, company response, and economic background are also key. Model performance matrix occurrence. The first bar on the left is the tallest, suggesting the model has the high occurrence close to the zero point 0.9 AVC area under the curve. The model bar slight shorter than the occurrence bar, indicating the strong AVC value, probably around the zero point 0.8 potential subscribe. The third bar about the same higher as the AVC bar maybe represent how will the model predictive capture the potential subscribe also around the zero point 0.8. Next will be continue the Karthik.
Myself, Karthik Aran. Now we are going to explain about machine learning techniques comparison. In that first one is neural networks. The key feature is neural network is high predictive power. Next one is support vector machines. This key feature is good performance. Next one is decision trees. We have to easily implement the decision trees for machine learning techniques. Next one is linear regression. We have to make a simple model in linear regression. Next one is random forest. We have to effectively classify the random forest. Next one is business impact on applications. In that first one is targeted campaigns. In this, more focused marketing efforts. Next one is reduced cost. We have to reduce the cost, low customer acquisition expenses. Next one is strategic decisions. We have to make a better business planning. This leads to more targeted campaigns and reduce acquisition cost. Enhanced strategic decision making is possible. The future of predictive banking. Why neural networks stands out? First one is neural networks are more powerful than other techniques. Next one is they can learn complex patterns in the data. Next point is especially useful when working with large and complex data sets. In this case, they performed better in predicting which customers will subscribe a term deposit. We compared to learning methods, while models like decision trees and SVMs perform well, neural networks gave the best results. Then their ability to capture complex patterns made them the most accurate in predicting customer subscriptions. In future of predictive banking, first one is model refinement, second one is complex architectures, third one is expanded capabilities. In this, the future involves continuous model refinement and more complex architectures. Expansion of predictive capabilities is key. Ethical artificial intelligence in financial services are essential in future. Thank you. Next, the actual code is how it works and the output my colleague or Ravi will explain.
Start. Good evening, sir. Good evening, everyone. I'm explaining to code. Important pandas as PD means important pandas a library used for data manipulation and reading CSV files. Important NumPy as NP means important NumPy used for numerical operation. From sklearn model selection and testing sets. From sklearn processing important stands discolor means important a tool to standardize features by removing the mean and scaling to unit variance. From sklearn metrics important accuracy score, precision score, recall score, F1 score means importance evolution metric to measure model performance, accuracy, precision, recall, F1 score. From TensorFlow, Keras models important sequential. From flow Keras layer importance means this dense important Keras classes to create a sequential neural network model and dense fully connected layers. Bank SCV means load the SCV files bank SCV into a pandas data frame called data. Data equals PD get dump place data drop to dummy one not encoded as one means removes the target variable ys from the futures x now contains only input futures. Y is equal to data ys means the target output variables y is whether a customer subscribed s equals 1 no equals 0. X train x test y train y test equals train test split x5 test tries 0.2 random state equals 42 means splits the data 80% for training 20% for testing random state equals 42 and just repeated results. Scalar equals standard scalar means creates a scalar object. Extend equals scalar fit transform extend means fits the scalar to the training data and transformation standard. Xtest equals scalar transform xtest means transform the test data using the same scalar do not fit thing. Model equals sequential means starts building a sequential model layers are added one other to model at dense 32 input dmx train shape 1 activation equals rule means adds the first layer 32 neurons input dm equals number of users activation equals real refracted linear unit Model dot add dense 16 activation rel means adds a second hidden layer within 16 neurons and neural activation. Model or dense reactivation sigmod means final output layer. One neuron equals binary classification. Sigmod activation means output properly between 0 and 1. Next will be explained by my friend Jitendra Patel.
Good evening, everyone. Good evening, sir. Now I am going to explain the rest of the code. Next, coming to the model dot compile loss is equals to binary cross entropy optimizer is equals to ADM and the matrix is accuracy. This purpose of this code is to prepare the model for training. Loss is equals to binary cross entropy means we use the binary cross entropy to measure the error. Next, optimizer Adam is used for efficient gradient descendant. Next, matrix is equals to accuracy. We track the accuracy as the performance metric during training. Next, is equals to model dot fix fit x train y train epochs is equals to 20, batch is equals to 32, validation split is equals to 0.2, where both equals to 0. Purpose trains the model on training data. X underscore train, Y underscore train the features and labels for training. Epochs 20 model iterate 20 times over the entire training set. Batch is to 32. The training data is split into batches of 32 samples. Validation underscore batch underscore size is equals to 32. The training data is split into batches of 32 samples. Validation underscore split is equals to 0.2. 20% of the training data is used for validation, where both 0 training progress won't be printed. Next, prediction and thresholding. Y underscore pred, which means the prediction is equals to model dot predict x test greater than zero point 0.5 and dot as type int 32. The purpose predicts the class labels on the test data. Model dot predict of x test gives the probabilities between 0 and 1. Greater than zero point 0.5 converts the probability into binary predictions values. Greater than zero point 0.5 become 1 else 0. Dot s type int 32 ensures predictions are integers. Next, print accuracy. Accuracy underscore score y test comma y pred. Next, print precision underscore score y underscore test comma y underscore pred. Print recall underscore score y underscore test comma y underscore pred. Print f1 score y underscore test and y underscore pred. Accuracy score calculates the total correct predictions and prediction and precision score true positive plus false positive measures how many predicted positives are were actually positive. Recall score and true positive plus false negative measures how many actual positives were correctly identified. Next, coming to the output, accuracy is 0.8891, precision 0.735, recall 0.628, and F1 0.677. These values summarize the model's performance on the test data. Even though accuracy is high, 81.1%, the lower recall and F1 score indicate the model may not be catching all positive cases, which can be important depending on the condition for fraud detection. Thank you. I hope you all enjoyed our